everybody. We got it. Ah, yeah, nice. We got everybody in here. We got people over on the ESPHome channel. We got people on the Home Assistant channel. Don't forget to like, subscribe to all of these things, guys. This is new for the ESPHome side of things. Welcome to our first live stream of the year. I called it the New Year Edition one because we are actually talking about the first release for ESPHome of 2025. So this is the New Year Edition. I'll actually introduce ourselves now. For me, I am Missy. I am actually the Home Assistant Community Manager, but I help out Jesse and Keith heavily on making sure that their stuff gets highlighted as well.
Cool. Hello, I'm Jesse. People should know me by now if you're watching. I work on ESPHome, keep the project going, and with me today is Clyde. Clyde is one of our contributors to ESPHome, and he's just happened to be visiting my lovely country, so we decided to meet up in person.
Yep, so here I am.
And I am Keith. I help Jesse with things ESPHome related and sometimes do a little bit of other hardware here and there for Nabukasa. But so we're here to just go over all the things today.
Yeah, we have the whole crew mostly. JLo really wants to know, is this the summer or the winter release? And I specifically said New Year to avoid this. Because
Southern hemisphere, northern hemisphere, no big deal.
For those new to this, Jesse is actually located in New Zealand. He's in the southern hemisphere. So when we talk about summer winter releases, it's literally the opposite for both of us. So trying to do it as a time frame of the year rather than the season. Oh, so what will this be about? It'll be about all the things, friend. It'll be about lots of things. So first thing it's actually going to be about is what's been introduced to ESPHome since our last live stream, which was in June. Sorry. We kind of had a big thing launch at the end of last year. I don't know if you guys saw, but it was a voice preview edition. And Jesse and Keith helped a lot on that side of things too. So we were a little busy. But we'll talk about what went into ESPHome over the past 6 months, talk about this release, and talk a little bit more about what we're going to do in the future. So I'm actually going to pull up Keith's little page here so we can get going for everything. Oh, someone wants to know, what is ESPHome?
Oh, that's a good question. And it's, I updated a document and put a nice little description of that somewhere. ESPHome lets you turn your little microcontrollers into smart home devices. So we have a lot of these really cheap, nice little, why do I not have one at arm's reach? What's going on? There you go. Actually, I do have my Adam Echo. But you can get a lot of different devices with these ESP microcontrollers in them, and also it supports RP2040. So there's some nice hardware out there that's very inexpensive. It's easy to tinker with. It's pretty easy to use, and so ESPHome eliminates all the boilerplate associated with using one of these embedded microcontrollers. So you can more or less just say, "I want a light." And now you have a Wi-Fi connected light bulb, for example. You've got to do a little bit of wiring and hook things up, but it does make integrating and connecting these things a lot easier, I would say. I don't know, Jesse, have you got any thoughts, input?
You pretty much nailed it. Yeah, it's when people think about microcontrollers, I guess your first thought would go to like, what language do I need to learn to program these things? And what tools do I need to compile the firmware and flash them? And do I need special flashes and all these sort of things? So ESPHome was made to take most of that away and allow you to write YAML configuration, which it can be difficult, but once you get the hang of it, it's not so bad. ESPHome itself as a program turns that configuration into the firmware. It does all the hard work. and including the flashing, and gives you over-the-air updates, and it just makes it so much easier.
If I can just jump in there too,
Go for it.
as a relatively new user and contributor to ESPHome, the thing that struck me most about it is the fact that it's like Lego. Everything plugged together. You've got all the components that have been written by people that are built, that are part of the core. And sometimes all you've got to do is write one line of YAML to enable that feature. Not only that, but all the other things that you can add on that maybe depend on that, like if you put a UART in there, a serial port, everything else that needs a serial port automatically works with that. So compared to conventional programming where you're having to learn APIs and connect one component to another, in ESPHome, for the most part, it just happens. It's kind of like magic, really.
Yeah, and building on that, that's exactly right. I think, when you consider all of the things that you'd need to do to make something like a smart light bulb work, you've got to worry about bits over the wire. You've got to worry about, pulses, PWM. You've got to worry about what messages you're sending over Wi-Fi and HTTP and how all these requests work and all that. ESPHome just does that for you. So in the YAML, you can write, 3, 4, 5, maybe 10 lines that just sort of describe this light bulb that you want. Is it just on or off? Is it dimmable? Is it color? And ESPHome does the rest for you. And then you're good to go. You have this light bulb. You don't need to write hundreds or thousands of lines of code to describe this API and integrate it, so on and so forth. So it really eliminates the vast majority of the boilerplate to get something like that going. Because, it would be easy to spend years building something like that. Ask us how we know. So
this is a great actual call out, making non-programmers feel like programmers. And I'm a great example of that because I have just started dipping my toes into ESPHome stuff, and I'm building up my own e-ink displays. And Jesse's had to absolutely walk me through stuff. But once he showed me the basics of it, now I can look at stuff and I'm like, oh no, now I understand what I need to change for this and what I need here. Once you look at it, it's very easy, especially if you understand YAML. Like if you know the YAML already, ESPHome will make it easy for you.
It does.
Yeah, like I mentioned, YAML can be hard to get started because of the highly enforced structure.
Indentation. That's the problem.
Yes.
Spaces. Yes, indentation. Yep.
Having the right number of spaces can get difficult if you don't know how it works.
Yep.
Yes. Absolutely. And JLo here talking about building any devices he wants. That's how I feel now. Like now just dipping my toes into it. Now I'm like, no, this is definitely something that I could do and it'll make it really easy for me overall. And it kind of gives that freedom of not having to rely on the hardware that you find and if it actually is going to work and stuff like that. It's been really, really fun exploring it as a new person.
Well, and also the range of things you can do, right? Like you can do something as simple as, I was talking about just a little Wi-Fi light bulb that turns on, turns off, all the way up through a voice assistant that you can talk to, and everything in between. Like I've built thermostats that, any whole range of sensors for monitoring temperature, power usage, you name it. There's really, yeah, exactly. You can put displays on devices, so the little sensor that's monitoring your temperature and humidity, you can see it right on a display, and you can even have a touch screen. So if you want to see different things, you can start to do that. And LVGL has added a lot to that. Tiny little displays like Jesse's holding up.
This is fully incorporated, right? There's an ESP32 S3 in here. It has a display on the front, USB-C for power. The display touchscreen, but it's a button.
And of course, one of the other great things about ESPHome is that it is tightly integrated with Home Assistant. You don't have to use Home Assistant to use ESPHome, but if you want to, it's simply the easiest way to get data from the real world into Home Assistant.
It just works.
MQTT, forget it.
I'm with you on that, Clyde. I'm not an MQTT person myself, but
don't start fights in my chat.
Right?
Don't
we're not gonna go down that road. But it is, and that to that point, you can, if you really don't want to use Home Assistant, you cannot use Home Assistant with it. That we have a lot of people, I know, Jesse and Clyde, I'm sure you've observed in the chat and in Discord, we have a lot of people who are just using devices with just the web server component, and they connect to them that way. And so, if you want to do that, there's nothing stopping you. So it's got a lot of capability.
Yep.
Awesome. Paulus, I don't know if you guys saw.
I saw. That's why I was laughing.
Yeah, he recognizes us as real people. He's met me. I don't know what he's talking about.
Jesse and Clyde are way in the future though, so they're like,
no, they're on Thursday already. Like they're way ahead of us already. All right.
Oh my gosh.
Okay, let's pull up these notes.
Release
let's
notes.
go all the way back, Keith. We're gonna go all the way back to July of last year.
Ooh, we want to go back to July. Okay, let's do that. I can go to our change log here, and whoop, I didn't need to go back. I actually just needed to scroll way down. July of 2024. Boom.
Ooh, we updated Micro Wakeword then.
This is an important one, yes. And we also there was the all the voice stuff that's been happening over the past couple of years now, right? Micro Wakeword was, I think, largely Kevin's baby. Correct me if I'm wrong, but got what's that?
It still is Kevin's baby.
It still is Kevin's baby. Yeah. But
it may have grown into maybe a toddler or a child.
Yes.
There's still more to come. There is still more that he has upgraded for the voice PE that is still not in ESPHome, and it will be coming.
Yes, lots of stuff in progress here. Continuing on the
I guess we should start with what is Micro Wakeword. If people don't know, Micro Wakeword is a on-device wake word detection system. So it allows the Atom Echo to detect you saying, I probably shouldn't say any of the wake words actually. Okay, specific word, or hey, specific word. And more recently, Kevin has created a sort of a tool set to allow you to create your own wake words with whatever words you want. It's not particularly great without a good training set, but it can work, and it does work, and it shows that with some improvements, maybe it will be, even greater.
Yep. This is very much continuing to evolve, and it keeps getting better and better. I think all of us have learned a lot. Certainly Kevin building it, and the rest of us, playing around and testing it, what works, what doesn't. And there's a lot of complexity here. I think it's important not to underestimate that. There's a lot going on under the hood here, and it's taken quite a bit of time to get it dialed in and really working even as well as it does. And I would argue, at least for me, it works extremely well. I'm quite happy with it. So yeah, it's this is huge. Having this run entirely on the device is quite a big accomplishment, especially as an open source project. So it's this was cool. It's really cool.
Yeah, before Micro Wakeword, Mike, who works at Nabukasa on Home Assistant, he created the add-on for Open Wakeword. The problem with that is that the ESPHome devices had to stream 100% of the time to Home Assistant so that it could detect the wake word, which was not great for processing, bandwidth. It just wasn't very good.
Yeah, I think, while at least in my experience it worked well, I think the bigger issue is scaling. Like, if you want to have a whole bunch of devices, you really don't want them all streaming, and then of course there's privacy concerns and other things. So that all plays into it.
I don't think there's too many privacy concerns. You can see all the source code. It should be good.
True. That's true.
And 10 devices in your house all streaming the audio. I mean, we have cameras, but it's for a different purpose.
Yeah.
Having these devices streaming when they're maybe not being used.
That's exactly what I was getting. Yeah. So, yeah, even though like Home Assistant is all local and everything is happening locally, there's still, if someone somehow has access to your home network, or maybe you've got an infected computer or something like that, you're just creating opportunities for things to go off the rails. And so by eliminating that and having it all happen on device, it's quite a bit. Yes, David actually created.
So David created OpenWorkWord, and it was ported to an add-on for Home Assistant.
That's Kevin. That's our resident.
Yeah,
he's the one who's been working on all this stuff for us. He's our resident smart guy.
Yes. So yeah. So this is definitely a big one to talk about, and this was definitely the highlight of the July release, as I think Missy was alluding to. Yes. So so what's next? Just kind of going over things in the past. Shall we move on, or do we want to?
I don't think there was anything else big in this one, right?
Yeah, let's take a look at August. Of course, this is where LVGL came in, and this is the online image and some other things. Clyde, do you want to talk a little bit about LVGL and what that was like?
Sure. So this is basically why I came into ESPHome, or at least got as involved as I did. So I had this project I wanted to do. I'd had some experience with LVGL, and then I found ESPHome, started working on it, had this project for which I needed a screen, a reasonable size, 4 or 5 inch screen, touch screen with some graphics on it. And the graphics that were available in ESPHome at the time were useful, but having experienced LVGL on other platforms, I knew that it could be a lot better. But LVGL didn't work with ESPHome. Apparently a couple of people had looked at doing it and thought it was too big a job. I thought it was too big a job, but I thought, let's do it. There were a few doubters at the beginning that it was going to work, and it took
me.
It took over 12 months of work.
Wow.
Yep. At the beginning, I didn't even know how it was going to work, how it was going to integrate into ESPHome. So step backwards. For those who don't know, LVGL stands for Little Video Graphics Library or something along those lines. It's an open source, which is important because ESPHome, of course, is open source. It's an open source graphics library designed to run on small microcontrollers. So an ESP is actually fairly grunty compared to some of the stuff it runs on. So it's a very good fit for that. It lets you do a lot of the kind of widgets and other graphic tools that you can have on tablets and computers, but in a very low footprint. Takes a relatively small amount of RAM, not too much flash memory, and it's reasonably fast. It's also modular. When you build it, if you are using some of the widgets and not others, they don't get compiled in. And it's a very well-maintained open source project that's been around for quite a long time. A lot of the commercial products that you see around the place build LVGL in for their own user interface. So with all of that great work that other people have done, I just figured, well, there has to be a way to get this into ESPHome, but more importantly, make it easy to use. LVGL in its native form requires you to be a programmer. It's C, it's not even C++. You've got to learn a big API. You've got to write literally screeds of lines of code just to set up every single widget. ESPHome's approach with YAML, whereby you, rather than saying how to do something, you tell it what you want to do. ESPHome translates that for you into the code that actually does it. And that's how I tackled getting LVGL in there. So instead of writing 16 lines of code to set up a label, in ESPHome now you can write probably 4 lines of YAML and you have a label. And it's pretty much as simple as that. You can get very complicated. I know there are some of the users who've put together massive interfaces in YAML, literally thousands of lines of YAML, but you don't have to start that way. You can start with just a few lines. and you get these beautiful displays that are the graphics rendering engine in LVGL has been fairly finely crafted over the years to be fast, but also does proper anti-aliasing, which was something we didn't have in the ESPHome display before. So everything looks nice. It's got a built-in touch screen and encoder interface, so user interaction is already there. You just again have to add a few lines of YAML to hook your touchscreen into your interface, and it just works.
Don't be like Snowy. Snowy's insane. 4,000 lines of code.
Yeah. And he's not the only one. So, yeah, that was what it was all about. And like I said, it was a big job. I had no confidence at the beginning that it was going to work, but it did. And it seems to have gained a lot of attention. A lot of people are using it, which is, for me, was the whole point of the exercise. Well, that and the fact that now I can actually get on and finish my own projects.
Nothing like a year-long detour, right?
Yeah, there was a lot of back and forth with the PRs and the branches to get everything in, and I forced a lot of rules on Clyde to get this in and make sure it was following the ESPHome standards for everything, and it was a lot of work, and it was great when it finally got there.
Yeah,
and it's not finished. There's still
never.
There's still some of the library that hasn't been brought into ESPHome. There's also an opportunity which I've started doing, and also the other gratifying thing is that now we're getting contributions from other people.
Mm-hmm.
It was a one-man or two-man job. I must make mention here of my collaborator, Robbie, who lives in Hungary, who jumped in fairly early in the piece and said, I can do the docs. He had some background with LVGL, and he's a good writer. And had he not stepped in, I would not have been able to complete the job, certainly not to the level that was required. So I don't know if he's watching this today, but thank you very much, Robbie. Your work was greatly appreciated by me and everyone else. So it was a team effort. But what's happening now is we're getting other people making contributions. So that's obviously how the whole project is meant to work. And it's gratifying to see that happening.
Yeah, I saw, I think there's a PR for charts, LVGL charts.
Yes, that's right, yeah.
So someone wants to show some charts, so yeah, they should come.
There's always more to do, right?
Always.
They're finished. You can't, they don't go together, those two words.
Yeah.
Nope. Never.
So,
always something new you can do.
Yeah.
So yeah.
Yeah, I guess in the same release, online image is another component that it goes well with LVGL now. It allows the ESPHome device to pull down an image from a URL at runtime. So up until this point, all your images had to be compiled in at the time you were writing your YAML. But now, yeah, dynamic, depending on if you have enough RAM, memory, obviously it has to store it somewhere. But yeah, this is allowed a lot more dynamic interfaces. Indeed.
Yeah, the RAM limitation is something we run into somewhat regularly on and you see that on any microcontroller, right? I think the ESPs have about 500 kilobytes of RAM, so you can fill that up. The cool thing about ESPs is you can have the PS RAM, which is essentially external RAM relative to the microcontroller core. So it gives you the ability to sort of quote unquote upgrade. You can use an ESP with PS RAM, and now you can get some additional memory to have larger displays and fill up more. So that's handy to be able to do.
Yeah, and that goes up to 32 megabytes.
Yeah,
you can get
I think so.
Yeah,
you can get pretty big.
Yeah, I think for our voice PE device, we have do we have 8 or 16? I can't remember.
16 megs of flash and 8 megs of PS RAM, if I remember correctly.
Yeah, and that's enough to do a lot of things when it comes to microcontroller world.
Yeah.
The interesting thing is that there have been quite a few people using LVGL on smaller devices without PS RAM on some of the smaller displays, which I kind of didn't anticipate, because you're thinking, when you've got something like the M5 display, you think, well, what's the point? But simply because It's easy.
You don't need to have a point.
That's very true. We see that a lot. It's because I can, not because I should. So it's interesting. But and the other thing too, the online image thing is cool because you can pull images and potentially even change the images at runtime. But one of the motivations for having larger flash on some of these devices is to be able to store images. So or in the case of Voice PE, to be able to store audio clips to play during as different things happen. What is JLo saying? I missed that.
He's going to use AI.
He wants to use AI, to generate all the images with LVGL and online image. So that sounds like something he'd do. Absolutely.
Yes. He's going to do it. There's no doubt about it.
And then I'll get it uploaded to the Home Assistant channel, and everybody will be able to see the ridiculousness that JLo does.
He's quick. It'll just take him like an hour, right?
Right? Absolutely. Done. One and done. He'll be fine. Don't worry. We'll have this by the end of the week, guys. No. There's a couple questions. Do we have, I don't know, I don't think we actually do though, have any examples of LVGL on a physical device right now? I don't think we do, right?
We don't have anything here, no.
Okay.
I do not have an LVGL device here at the
No
moment.
worries. I'll poke you guys for some examples later so we can make sure we get people seeing what it looks like.
There are definitely lots of examples online, people posting their projects. If you look in the ESPHome Discord, you'll probably find something.
Oh yeah. There's and they're continue every day. There's more. There's LVGL is quite popular, and there's an entire channel in Discord just for LVGL stuff. So if you do have any questions or you need some examples, join us on Discord. We have a whole channel, and that's all they talk about is LVGL and displays hardware to some extent. But yeah, so. Cool. Well, just in interest of time, shall we move on to what we did in September? I think probably UDP is the big one here.
Yeah. So along the way, actually after I'd basically finished LVGL, or at least got it to the release point, one of the things that we were talking about before about using ESPHome without Home Assistant, communicating between devices. So there's lots of times when you've got a sensor on one ESP device and you've got a controller on another, and you can do automations through Home Assistant to have that sensor control that device. But people think, well, what if Home Assistant goes down? Or I just don't want to use Home Assistant because I don't need it for anything else. So I'm thinking, well, we need a way to have one ESP device be able to send data to another one directly, and the simplest thing at the time seemed, well, let's use, we've got Wi-Fi. Let's use some UDP messages. It has its limitations, but basically it's a simple protocol where one device can broadcast sensor and binary sensor data, and other devices can receive that and act upon it. It has some encryption features if you're concerned about people snooping on your local network. And that's basically what it does. So again, it seems to have been fairly well received. I know a lot of people are using it. And it's probably, we've had some more stuff coming in just recently, which didn't make it into the last release, but there will be other communication channels, UART and the like, building on that. So it just, in a very simple, low footprint way, it lets you have one device talk directly to another.
We get requests for that a lot more often than you might expect. Devices communicating, directly peer-to-peer, and be it over wireless connection or a wired connection, serial via UART, something like that. I think there's a need for that.
I looked into creating an API client on the device as well, so it would talk to the native API and have the communication. But then I was like, I started looking into it, and I was like, this is going to be very difficult. So I'm not going to do this for now. And with what the community brings,
and that might still be something worth doing in the future, but
it's not off the table, right?
Certainly it would have been a much bigger job. The UDP one was designed to be very simple,
Yes,
while still offering some security if that's what you need. And it can also work into remote networks. You can actually have it sending data to something that's not in your local network. So it's got a few other applications as well.
Mm-hmm.
Yes, indeed.
Why are you in 2022?
Because I clicked on totally the wrong. I went down way too far, and then I confused myself and clicked on the wrong thing. There we go. I thought that looked a little bit off. Okay, audio stuff. Yes.
I'm glad I could read.
And I'm like, wait a minute, this doesn't look right. Yeah.
Like, I just looked at this page. What do you mean this is not Bluetooth? What?
Bluetooth. Yeah, we could talk about Bluetooth proxies. That's a whole nother topic. A great use case for ESPHome. But yeah, this October brings us into some of the audio stuff we started doing, which secretly under the hood was for voice PE. Although nobody really knew it yet, but that's that's what this was aiming towards. There was the
it was secret, but we had the public firmware repo.
True. Yeah.
So
it wasn't a will.
It was a secret.
Yeah, and we joked about it on every Home Assistant stream forever. Like it was an open secret, but it was definitely like secret.
You know.
Exactly. Yeah. But this was kind of the beginning of. Oops, sorry. Go ahead, Jesse.
Go for it. You created something. So
that's true. Yeah, I spun up the audio DAC core. In ESPHome, we have hardware components for something called an ADC and a DAC, or DAC, if you like to pronounce your acronyms. But basically, ADC is a way to take an analog signal of varying voltage and convert it to digital. And then DAC is the opposite. You take a digital signal and you convert it to analog, for example, to drive a speaker. While they're kind of conceptually the same, we handle a DAC or an ADC for just taking an arbitrary input signal versus taking an audio signal. We treat those a little bit differently. There's more complexity with the audio stuff. Generally, there's additional processing that goes on, maybe noise reduction, echo cancellation, other things. So we realized that there was a need for kind of an additional layer in ESPHome to deal with processing audio, and specifically with the hardware associated that's external to the ESP. And so that brought rise to this audio DAC core. And we also now have an audio ADC core, which we'll talk about later. But this enabled us an interface to the various hardware components. These are actually like chips on a board to do signal conversion from a digital signal generated by decoding some audio data, and then bringing it to be analog so that you can play it back on a speaker and actually hear it. So that was the purpose of building this this architecture, to give ESPHome a way to deal with that and make it consumable in the way that ESPHome does. You can put a few lines in your YAML to describe which particular audio interface you've got, and now you've got a way to talk to that, and you don't have to write thousands of lines of code to do it. So it's pretty cool. So this was kind of the start of that. Jesse, anything you want to add?
Yeah. So the audio DAC core and coming up the ADC core code is by itself is an interface for ESPHome to control these different DACs and ADCs, and it allows us to, for the DAC, it allows us to do like volume control, muting and stuff, and that's so that we have a common interface for volume across all these different ones, because they all implement them in different ways, which is exactly what ESPHome does overall, right? It gives you a very common YAML interface for different chips, different sensors, different switches, whatever you want. We're trying to make it easier. So this allowed it to make it easier on ourselves when we implement the different components.
Exactly. Yeah, and those interfaces, we use the word interface, which might sound a little, complicated or deep, but those interfaces are what allow you to do something like volume.up or, volume.down. And so you can change the behavior of a particular hardware component with just a single line of YAML, right? So it makes working with ESPHome much easier to have these things. And then you're not trying to write C code and lambdas and all this stuff. It can get messy quickly. So yeah. So that was kind of where that came from. And another just kind of shout out here. I mean, you see we have several more sensors being added here and whatnot. We're always like, almost every release, there's like a new sensor or maybe an IO expander or input device, something like that. And so this is a great example of just adding support for more stuff. It's always growing. Okay, so let's go back to
one comment. Someone asked if there about plans for peer communication via Bluetooth.
yes.
And so there are no plans. Okay, this is an open source contribution driven community, so there are no plans. But it might happen.
Yeah, and that is an important call out too. I think we do. We have quite a bit of a request for plans and things, and I think the work that we did on voice was very much planned. Like that, we knew we were going to do that, and it sort of took form as we were going. But nonetheless, I would call it planned. And some of the other things that happen, even something like LVGL, we didn't really plan that. Clyde was nice enough to contribute time and build that out, and it took some time, but here we are. If you had asked us 3-4 years ago, are we going to have LVGL support? I mean, we would have gone, yeah.
Maybe. That plan is no plan.
But
Paulus
as Paula
is 1
says,
hour
yep.
project.
Best plan is no plan. Yeah, and so it's difficult because we do get asked that a lot. What are the plans? And it is a difficult question for us to answer. I'm sure we would love to be able to give you a very specific answer, but that's just not how it works.
But the great thing is that because there are no plans, there are lots of nice surprises.
Yes.
That's a very good point. Very good point. So you can be surprised when these things appear.
Coming back to the Bluetooth, right? ESPHome supports being a Bluetooth client, so a device that connects to another device. It also supports being a server, and I believe recently there was a PR merge, and it might even be released now, that allows you to define different Bluetooth characteristics on the server. So technically, you can write both sides of a Bluetooth connection in ESPHome YAML and connect and send data.
Yeah, you can.
It's done. It's not.
At this stage, you have to do
a lot of work.
you have to put a few lambdas in there to actually format the data. But I think the question there was something like the UDP component, but using Bluetooth.
Yeah.
And like I said, there are no plans, but I have been looking at using extended advertising and possibly periodic advertising in Bluetooth, which is a Bluetooth 5 feature. ESP32 support Bluetooth 5, and it definitely has the capability to do that. So just watch this space.
Stay tuned. Yes. Cool.
Yeah.
JLo is here for our chaos. Absolutely. This is what we need him around for. He is absolutely our peanut gallery this live stream. Thank you, JLo.
Yes, indeed. Yes, indeed. Cool. So, here's November. We've got another audio component. OpenTherm came in. OpenTherm was actually a big one, and I know almost nothing about OpenTherm. Jesse?
We don't use OpenTherm. We don't have central heating here in New Zealand as in other countries. So I literally have no idea about it.
Okay, so I'm not alone then.
It's not really a thing here. So
I haven't seen it. It might be in more commercial spaces in the US here. I'm not sure. I just honestly don't know a lot about it. But I know we have a very enthusiastic community around it.
Definitely, There was it OpenTherm? it might have been OpenTherm. There was 3 different PRs from 3 different people trying to get OpenTherm into ESPHome.
Yes. Yep.
So I made a discussion on GitHub and said, here's the PRs. You guys discuss which one you want to put in, and I'll take it from there and review that one. And so they talked together and they decided which one and worked together and got it in.
This is one of the surprises that comes up, as we were just talking about, you know.
Yeah.
So there's,
from what I understand in terms of reviewing the code, it's more of, I think it becomes like a man in the middle between the actual header and then the control panel.
Yep.
And allows you to read the controls or inject controls and get the sensors out of it, and mostly things like that. It doesn't implement an actual climate entity. That's up to you to implement yourself with templating and whatnot, but it gives you access to all of the actual data.
Mm-hmm.
Nice. On the Bluetooth thing, I was waiting for B Draco to get talked about.
Called out,
yeah. When we're talking about Bluetooth, we have to talk about B Draco.
We do, yeah.
Absolutely. So he's trying to make it easier for things. Python scripts? That's crazy, Paulus. What? Jeez. Like, we're just trying to make everything easy for people. We're removing the magic that a lot of people see that when they use Bluetooth or Wi-Fi or something like that. We're opening up the magic. Like, we're showing them how it works. I'm excited about it. Really.
It's really cool. All these things come up that just enable, and some of them may not sound like big changes, but they enable things that are quite significant. And it's not always immediately obvious that that's what's happening or that's what's going on. Certainly, B Draco has done so many Bluetooth things all over, and ESPHome and Home Assistant alike, right?
He's in everything.
Yeah. So it's crazy, but that's the thing. Like, Bluetooth support and Home Assistant in general has come a very long way over the last couple of years. So like that's huge. There's something to be said there, and it allows us to use even more devices, which is the whole point. So it's pretty cool. Anyway, let's jump into, what did we have in January?
We didn't do a January release.
That's right. We didn't do January. We just went straight into February.
Yeah, I took a holiday.
Good.
We had a holiday.
As you should. Like,
Yes.
Take your holiday, take your vacations. That's fine. It was a small release anyway. There wasn't big. That's fine.
It was. The releases to the end of the year can be a little bit smaller. There's holidays and things going on. So it is what it is. But so then I guess that brings us to today.
Yeah.
So here's oops.
Okay. So we're now here. I mean, that was yesterday, but
True.
For you.
Anyway, as you can see there, we've got the audio ADC, which is sort of a companion to the DAC. So ADC is for microphones, DAC is for speakers. The common interface for microphones allows ESPHome to set, I think mostly it's only the gain on the microphone, which is, input volume for microphones. And then you can see in the middle row there, we have the line of ES. The ES chips are the DACs and the ADCs that the ESP32 S3 boxes all use, which is the devices that we initially created the voice assistants on, apart from the Atom Echo. And so Keith and Kevin have been working on these components so that we could drop quite a big dependency, which is ESP ADF, which we were using for these microphones and speakers. But we didn't have much control over. It was a semi-black box kind of library provided by Espressif, which wasn't very nice to use. So props to those guys for working out how the actual DACs and ADCs worked and created components so we could use them directly.
These were a bit tricky to get going because there's very, very limited documentation for most of them. Yeah. So we largely, admittedly, were copying more or less, not straight up copying, but like we had to make some adjustments for sure. but to integrate with ESPHome, yeah, we had to do a good bit of reverse engineering to understand what the communication is. Was it the 7243E? I couldn't even find a document for that. I mean, there was like nothing other than just a general like marketing overview of, yeah, it's an audio chip. Like not very useful in terms of development. So
pay lots of money and buy lots of samples to get
yeah. So, we did get them going, and so this is all integrated. And moving away from ADF was important to us, at least because it would break things in ESPHome. It sort of just takes control of the whole device. And we wanted to have the ability to independently control, the DAC and the ADC and some of the other components, particularly things on the I2C or I2C bus. So being able to move away from that is actually quite an improvement. And I personally will say that I think the S3 boxes work better this way than they did with what we were doing before. Just having played around with them a bit, there's an improvement, I think, in terms of responsiveness, and also just it's more responsive in general. So like when you talk to it and when the playback happens, you can adjust the volume and all these things. Like it works better.
Yeah, and the previous code, when we're using ESP-ADF, to output some bytes of audio to the speaker, it has to go through a whole ADF pipeline and do all these different things that we had very little control over. So yeah, now it's basically the bytes go straight out to the I2S bus and sent straight to the speaker, and you hear it.
Yeah. So in any event, if you're using S3 boxes, I think we still have a couple PRs we need to merge in the firmware repo, but we will do that, and you'll be able to update your S3 boxes, and you can try this out and hop in Discord and jump in the voice channel and maybe let us know if it's an improvement or not. I think it is. Anyway, but shall we move on? Should we?
Yeah. So the other components created for this release, speaker media player, mixer speaker, and resampler speaker. I couldn't quite read it. Kevin, again, he's back. He's been working on a media player for ESPHome that didn't require Arduino. So up until this release, we had a media player for ESP32s, but it was using an Arduino library, which we're trying to move away from using Arduino libraries because they're very restrictive. I had to fork the library in the first place just to get it to work with ESPHome, and it's not nice trying to maintain a fork of a library, which is actually quite a big library. So that library became unmaintained. My fork became unmaintained, really, and just because it just worked. But no updates, no control over specific things. So yeah, Kevin had been working on a new media player. Of course, this was mostly for the voice PE, but the work was always intended to be moved into ESPHome so that any ESPHome device can utilize it. And it's a significant improvement. It supports playlists, as in you can queue up audio files to play before and after certain things. Along with those, the mixers and the resamplers allow different speakers, different bit rates, sample rates. And I'm not a super audio person, so if I'm butchering this, sorry. But allows converting of the different sample rates from certain microphones so that they all match for the voice assistant. The voice assistant in the ESPHome or the assist devices, the microphones all use 16.
I think it's 16-bit.
16-bit, 16 kilohertz, 16 something. the terms here. But anyway, different hardware have different bit rate, sample rates, and so this allows it all to get mixed into the correct format. And it does it very efficiently. And Kevin's done a lot of work there. Playlist isn't exposed. We'll get there. Yeah. But internally, in your YAML configurations, you can queue up audio, and so things like playing a chime before playing the audio output text and things like that, I believe is what it's intended for. So the speaker media player is definitely a big addition, and it will be coming to all of that, like Keith said, all of the S3 boxes firmwares that we have. They will be updated. The PRs are all open, and we just need to go through them and merge them all to release and make a release so that the firmware for those boxes are all updated. If you have not taken control of them in ESPHome, then you should get a firmware update notification in Home Assistant, and you'll be able to just update, and you'll just get all of the new features and functionality. If you have taken control, then you will need to update manually from your ESPHome builder.
Yes, there's a good number of changes there, so that might be a little bit a bigger lift this time than in some of the changes we've made in the past were a little bit lighter weight. But there's a lot of changes in here between the media player and the new audio components and whatnot. So keep that in mind. Shall we, Clyde, you did XXTT, right? Did you want to talk about that?
This is something that won't affect most people at the moment. So we talked before about the UDP component, which allows you to send data directly between ESPHome nodes, and it has a facility for encryption. So the encryption module that's used for that is called XXTEA. It's a very lightweight encryption, fairly secure. It's only got one known vulnerability, which is not an issue the way we use it. And it's very small. The amount of code it uses is tiny. It's very fast. And it's been around long enough, so we know. So I used that in the UDP component to do the encryption. And that's been working fine. But at this point, looking at using splitting that component apart into its various bits so they can be used on other transports. So we talked about Bluetooth, we talked about UART. I saw a question there about LoRa. All of these communication channels are potential candidates. I say no plans, just candidates for direct ESP to ESP communication.
I've seen messages, people asking about ESP Now as well, which is another one.
The ESP Now, it's got some issues. We'll talk about that some other time. But anyway, they're going to need the same encryption. They're all going to need the same packet transport formatting. So the first step towards that was to split out XXTEA into a separate component. And it's at the component level, not in the core, because we've realized recently there's a lot of stuff that has been in core that actually doesn't need to be there. It can be its own component, and you just auto-load it or bring it in when you need it. So that's what XXTEA is. So if you want to use it right now, you have to be a programmer. And for that matter, even when it is incorporated into other components, it's going to be pretty much under the hood.
Transparent, yeah. You wouldn't even notice.
So that's the background, and it just happened to end up there as a new component.
Yeah, any new components in there, anything that GitHub marks or the bot marks as a new component, the scripts that I use for releasing put it here, and I see it and I put it in there anyway.
Yeah,
because it's still new component. Exactly. It's like, oh, what is this? It piques interest.
Yeah.
So.
And the SDL2 keyboard there, something just harking back to LVGL again. Along the way, there's been a lot of support added for display drivers. So a lot of these boards that have come out that you can buy on AliExpress and other sources that have an ESP32, often an S3, paired with a decent size, reasonably high resolution LCD screen, and a few AMOLEDs as well. They all have different display driver chips, and there's been a lot of those added over the last 12 months to really vastly expand the range of devices that you can run LVGL on. One of the things that people kept saying was, well, if I want to prototype this UI, this user interface layout, and I've got to recompile and flash my board and test it every time, it's slow. So there were a couple of a couple of components that were put together, one of which has made it into release, which is SDL2. It's a display driver that runs on most desktops. You can run it on Android, Linux, Windows, Mac, and probably some other things. It lets you write an ESPHome program, obviously not using very much in the way of other hardware, but you can have a display, you can have a touchscreen, you can have a keyboard, and it takes a few seconds to compile on a desktop compared to, a couple of minutes to compile and flash something in hardware. And the keyboard was a contribution from someone whose name I don't remember, who has added the ability to interface the keyboard through that display as well. So it just makes it's probably less for production use and more for prototyping and development, but a really useful tool.
I tried to spin up a live demo, but I don't have a configuration set up at the moment. Basically, if you've got a device like this, right, you have to compile and flash the firmware every time you change something on your display. I mean, any display, doesn't have to be this small, but you have to compile, flash, and restart the whole device, basically, to get your one little tiny text change. The SDL drivers allow you to do it on your computer, and it actually pops up a window on your screen. Mm-hmm. And so, like Clyde said, it takes a couple of seconds. It really does. It's so easy it would have made your development so much easier for LVGL.
Yeah.
It's way faster to iterate. Yeah.
So much faster. If you're creating a very big LVGL project, you really want to use this in the development phase. You don't want to put it on the device. You want to just do it on your computer because you get the touchscreen input as well. You can use your mouse as a touchscreen. And now you can use the keyboard for, I think they're just binary sensors, but that can lead to more stuff in the future.
You can actually intercept other codes as well.
Is it just a trigger?
Yeah. And sorry, the thought's gone out of my head now.
That's all right.
So what I was going to say was the thing with this is that you use the same YAML config for that as you will do on the actual device. You've got to be a little bit clever about how you structure it because, as I said, the sensors may not be available. Home assistant sensors are available in SDL. But there's been a couple of guys who've done some projects that they put on GitHub where they've done some really clever modularization of the LVGL config so that you can have a single user interface config that you can test and use on different devices that have different hardware or running on SDL. So again, it's another example of the way all of this stuff spawns its own knock-on effects and other people jump in and just add to it. It's a real network effect.
It is, yes.
Yeah.
That's great. It sounds like all of the work that I'm doing into my e-ink project is going to be going completely out the window in a few months.
So e-ink's not quite supported by LVGL, is it?
No, it's not. Yeah, when I was looking into it, it was different. Yeah.
Yeah, it works, but it's not very good. And that's an area that's maybe somebody else will jump in and sort out. I've got a whole bunch of e-paper devices at home, but I've never really used them for anything. So it's not my area of expertise, really.
Yeah, finding the right use case for e-ink is difficult.
It's surprisingly hard. Yeah.
Yeah, I've got one e-ink. I've got two e-ink displays at home. I don't use them specifically for anything, but they have touchscreens. And so it's like, well, now I've got to create this static, basically, display for it that has, dynamic data on it. But then it's got a touchscreen. So what do I put on there that I can touch, but that's not going to show me something instantly, but maybe it will just do something. And coming up with a very good use case is difficult for these kind of devices, but they are pretty cool. And
they are. Yeah. And unfortunately, the cheap e-ink devices that we can buy at the moment are typically the refresh, even with partial refresh, they're slow. Some of the new ebook readers with e-ink displays are much, much better.
Yes.
But until that technology filters down to the low end, we're stuck with the old style stuff.
Yeah, Amazon's definitely not sharing its Kindle technology.
Yeah.
You can scroll and everything on those things now. It's like, and actually, I think you can buy Android phones that have e-ink displays, and you can buy laptops with e-ink displays now.
And the Onyx book and related devices, they're pretty good.
Yeah. I think Remarkable is something in an ad I keep seeing.
Yeah, I was going to mention Remarkable. Yeah.
Like,
and these are big screens too.
But they're expensive. Very
Yeah.
expensive for that sort of technology still.
That is, I was just talking to someone earlier about that. E-ink displays do tend to cost more, especially given what they are. I like them. I think they look cool, but yeah, I haven't found a use case that I'm really like totally in love with. It's like, gotta have it, you know.
Yeah, for what I ended up doing, because the like cost for those ends up scaling significantly once you get larger. Like you can get a little 2-inch by 1-inch for fairly cheap in all reality. But I just bought them all separate so that I could put them into a picture frame myself. And then like it makes it a little bit easier. But then I found out how much coding I actually have to do to display everything in the first place. And that's where I am now.
It's a bit of work, but it's worth it.
But I think it's fun. Yeah, absolutely. It's great exercise in building hardware and understanding how to use ESPHome. Honestly,
it is. Yeah, it definitely is. So, why don't we move on and we'll talk a little bit about everybody's favorite part of a release, because I think there's a couple things that we should mention that are kind of important. Of course, here's the link to our live stream if you need to get back to this. But we do have a couple of changes in this release that it's already come up on Discord that some folks are going to be a little bit thrown off by this. So just getting back to this, so there's a couple different ways when you build an ESPHome configuration that you could specify the particular board and microcontroller you're using. And in this release, we got rid of the old way. So there's, I will avoid going into too much detail right now, but as it's
3 years ago, we made some changes to improve support for different devices and different frameworks. So the old style that we talk about here has been deprecated for 3 years. Every time you used it, there was a warning in the logs. So don't say we didn't warn you that it's going. But yeah, you can see there on Keith's screen, the old styles at the top where you would have the platform inside the ESPHome configuration as being like ESP32. But now with the modularity of ESPHome, we've moved to using components for everything. So ESP32 itself is a component, and that defines the chip and the GPIO pins and all of it's basically the hardware abstraction layer, or the HAL, as a platform, as a component. And it has made things so much easier for new chip support, the RP2040, for instance, the Beacon chips that run LibreTiny. All of that is possible because of the host, which is used for the SDL display drivers on the computer. Without moving to that newer format a few years ago, we wouldn't have been able to do that.
So there is the why. It does make adding support for things much easier in terms of the code. So it's an important change, and I'm quite certain some people will trip on this. And sorry, but again, this is something. I mean, look at the PR number. It was 2303. This is PR 8118. So we've come a long way. So be aware of that. Spread the word. Like I said, I think some people will run into this, but it's very much worth calling out. And then, of course, there's a link to the documentation. So if you look at the the current set of microcontrollers that we support, this is all here, and these changes are documented. So if you drill into one of these, you can see it explains the new style arrangement, and even for the 8266, which is a bit older, and we're kind of recommending people not use the 8266 anymore, but that even has its own component as well. And of course the RP2040 is here, so be on the lookout for that.
Documentation for ESPHome always shows the current recommended way of configuring something. So
Yes.
if you've got a configuration and it doesn't work, and you look at the documentation and it's completely different, it's probably because you missed some breaking changes along the way where we changed these things. All breaking changes end up in the change logs. I know many people do skip releases, and therefore skip the breaking changes because we can't just paste them to every future changelog. It doesn't work like that. We link them. Each changelog links to every previous changelog. So
there's that. And yes, also and people skip releases, and they also skip the documentation. Check the documentation. Read the docs. As I hate to push that on people, but it's true. All of this stuff is in the documentation. And as we move into the next thing, removal of custom components, these are things that we've had them flagged for a while in the documentation. Custom components is kind of the other big one I think that people will stumble on. We now have external components, and we've had external components for some time. And I wrote this a note about custom components that just talks a little bit about what is the difference between a custom component and an external component. And I think that kind of the key takeaways here from this are external components are just easier to use. You can configure them entirely in the YAML. You don't need to copy and paste large blocks of C code, and you don't need to save them in special files. You don't need to copy files into your Home Assistant instance, whether you're using the add-on or if you're running it locally and so on. So it eliminates more boilerplate associated with using components that are not specifically a part of ESPHome, that are not in like ESPHome releases. But it still allows a way for contributors, or you can even use PRs, components we haven't merged yet. It allows an easy way to use those things just by way of YAML. Again, you don't need to copy files. You don't need to paste code. None of that. It kind of just works. It's a really nice mechanism. Now, the caveat is that it does take a little bit more work from the developer up front. The kind of the difference is between a custom component and an external component is what bits of code you have. And the main thing that I called out here is these custom components are just runtime. They don't include config validation. So that's why you don't configure them in YAML. They need that part in order to be usable by way of the YAML configuration. And then of course, code generation as well. So it's a little bit more work to build it up front, but it makes it so much easier for anybody to use. Again, you're not copying files out of repos and some such. So that's the motivation here. Is it's just hacks on steroids. That's it. There you go. The main point is we're just trying to make it easier for users, people who are not developers, people who don't understand where they need to copy files in their config directory and Home Assistant so the add-on can consume them and all this stuff. It eliminates that. So that's why we did this.
So as a very brief overview of it, it allows people that are the developers for new components to actually create a new component. If they're not ready to put it in as a pull request into ESPHome, or potentially they have put it in as a pull request, it allows the users who are not developers to use that component with, I think, a minimum of 3 lines in YAML. And you've got 3 lines to get the component from, say, GitHub into your local system, and cached in there locally, and then whatever lines required for the actual component as if it existed in ESPHome at that point. It just makes that whole process easier for everybody.
Yep. And even as you get, let's say, for example, there's a new component that you're excited and you want to use, and there's a PR open for it, you can add that PR into your existing ESPHome device by way of external components. And what's really cool about it is if that PR gets updated, let's say something's broken and the developer needs to fix it. When the developer for that PR, the contributor for that PR updates that PR, you automatically get those changes. You have to rebuild you have to update your ESPHome device, obviously, but like you don't need to copy code and like update these files that you already copied from the PR. Like you don't have to do any of that. Literally, when you rebuild your device, ESPHome will just see that the PR is updated. It'll grab the updated code and it'll use it. you don't really have to do anything other than update your device. So even something like that becomes a much easier task. So yeah. So that's where this is coming from. Cool. What else do we have?
Well,
ARMv7.
ARM7, yeah. So ARMv7 has been a thorn in our sides for a little while with ESPHome. We've had to, up until now, customize our Docker file for building our images specifically for ARM7 and have conditional statements to install different tooling, and some things didn't work and all of these things. And then even once we got it working and people installed the ESPHome builder on their Raspberry Pi 2 or a 32-bit Raspberry Pi 3, it would take an hour to compile, or it would just fail because there's just no memory or processing available. So we made the decision to remove the ARMv7 support from ESPHome. You can still run ESPHome compiled on like a Raspberry Pi 2 if you were not using Home Assistant OS. I don't know why you would, but you can. ESPHome itself is still just a Python application for the builder side anyway. But we just had to make the decision to stop supporting ARMv7 in terms of Docker containers and the add-on for Home Assistant. It just became too much of a burden. So if you are running Home Assistant OS and you have ESPHome Builder and you're using like a Raspberry Pi 2 or potentially a 3 with the 32-bit OS or some other single board computers, and you're not getting the February update, this is probably why. It just means that you either have to stay back on the version or run ESPHome on some other device like your laptop or your desktop. You can run ESPHome anywhere that Python can run. You don't have to build your configurations inside Home Assistant. And I personally build my configurations on my laptop, and
same
from scratch, it takes 30 to 40 seconds for it to compile a full configuration. It's much better than running it on any of the single board computers.
Yeah, and I was going to mention that the in particular with ARMv7, I mean, running it on a single board computer, doing ESPHome builds on a single board computer is generally pretty slow. It takes a while, even just to update a single device. If you're doing that on ARMv7, you're obviously going to be running an older system like Jesse mentioned, a Pi 2 or Pi 3. I'm going to be brutally honest here. Don't do that. Just don't do that. You're kind of asking for trouble. So I really don't want to tell people that you need to get rid of your old hardware, but like this is an application where just don't. You can use it for something else, but not this.
Well, Home Assistant still works.
Right. True. That's also true. Yeah.
Home Assistant still works on these devices, and it will continue to work for some time. I think at some point they will remove ARMv7 support. I don't know. I don't follow the internal discussions there too much, but it's going to continue working, and there's no immediate need to get rid of supporting those devices for Home Assistant itself. Just don't try and compile your ESPHome firmware on them.
Exactly. Yeah. But I would argue I'm not even certain that running Home Assistant on a Pi 2 is the best experience right now. It might work, but
it depends on your needs and how many
devices
you've got and what.
True. If it's a slim install, it's probably okay. But yeah. In any event, I digress. Let's move along to some IDF5 related changes. One of the things that we forgot to mention earlier was last year, was it November, December, we switched from IDF 4.4.8 being the recommended version to IDF 5.1.5. And this brings us the benefit of some new APIs and other perks, fixes, and whatnot that are in ESP-IDF. What is ESP-IDF? We should probably, let me give you a one-liner. When you write a bunch of code for your ESP microcontrollers, Espressif, who makes the ESPs, or designs them at least, they make available a development framework, and that is actually the IDF Integrated Development Framework. And this is what gives us a quick, easy way to use all of the bells and whistles that are built into these ESP microcontrollers. Something like a UART for serial communication, or I2C, SPI, PWM if you're like dimming LEDs, making lights with the beeper. Wi-Fi is a huge part of that. Yes, absolutely. Bluetooth. So all these things are provided by ESP IDF, and ESPHome uses that underneath all of the components that we support, be it sensors or lights, outputs, the various things, switches, and so on, to facilitate this kind of glue between our code and the actual physical hardware. So we've moved from IDF 4 to IDF 5.1, and that actually, I will say, I feel like it went pretty smoothly. There were certainly
it was a very big task though, and it took a long time.
It took us almost, I would say, about a year. Another, Clyde LVGL for a year. I think it took us to just to get everything ready between, kind of reworking the way our tests work, and then doing the various components. We did have a lot of contributors who have contributing fixes for IDF 5, and even now IDF 5.3, which is probably a little ways in the future, but it's there. So yeah, there was a lot here to get that change complete. And so this particular change, the RMT updates, are moving us off of an older interface to the RMT hardware. And if you're not familiar with what the RMT is a specific piece of hardware in the ESP32 series that allows you to generate a very specifically timed sequence of pulses on a particular digital I/O line. It's frequently used for things like infrared or radio frequency RF remote controls. So if you're sending messages that way, but also we can use it for things like WS2812 style LEDs, where you've got a specific signal, series of pulses you've got to send over a single wire in a serial format to get the data to these LEDs so that they display the right colors and intensities. This particular hardware component had its software interface changed quite significantly from IDF 4 to IDF 5. And so there were a few changes, and one of our contributors, thank you, was spent some time and reworked this a good bit. And so there's actually a few benefits we picked up by having this change made. You can fine-tune things a little better now. In particular, the support for the variants is much improved, like the C3, the S3, and even the C6 for that matter, which we can talk about later. But yeah, so there's a minor breaking change. You might have to remove a line of code from your YAML if you're using this for either LEDs or remote control, RF or IR. But other than that, it's actually a change that I think most people won't notice too much, but the config validator will tell you if you need to remove this. Specifically, it's the RMT channel line that you may need to remove.
Yeah, there's a couple of different configuration changes along the way there. As I mentioned before, if you look at the documentation for your platform that you're using, you will find the most current, up-to-date configuration variables that are available. If you've got one in your configuration that's not showing in the documentation, it was probably removed. The way we make the changes in the code is we keep the variable available in the code, but we actually throw an error directly on it. And that stays around for a long time so that people don't just get generic, this thing is not available at all. We do have, a message to say it was removed at some point.
Yep.
So hopefully it doesn't affect too much.
And if it does, if you do stumble on it, it really is just remove that one line. If you happen to be using multiple RMT channels, for example, I've got an IR blaster where I've got a WS2012 LED and I've got an infrared transmitter. If you're using a couple different RMT channels, you might need to do a little more fine tuning depending on exactly which ESP you're using and so on. But again, this is all in the documentation, so I'm not going to do a deep dive into it right here, right now. But of course, we can help you on Discord too if you join us over there. There's plenty of people who are very familiar with each and every aspect of the ESPs and then the changes we're making. So, so there you have it. Moving along, audio components. We talked about this a good bit already, so I probably won't spend a lot of time here. This just kind of calling out the changes related to the S3 boxes, the new components, speaker, and then of course the mixer and whatnot. So those things we went over already, and then of course the image components. Do you, Clyde? Do you want to talk about any of these changes at all, or?
Yeah, sure. So they're not huge changes, but the image component, of course, originally only worked with the ESPHome display driver. With LVGL in the ESPHome style, obviously we wanted to keep the image and make the ESPHome image component work with both the classic display driver and LVGL. But LVGL's got a lot more capability in terms of displaying images. And there have been some changes here to, firstly, make more use of that, but also to enable configuring it a little bit simpler. So in the past, you simply said this is transparent or it's not. Now you can specify, well, what kind of transparency you want, whether you want something that's, it's either the pixel is on or it's not. Now we've got anti-aliasing and alpha blending available there. And you can group components. And so all of these need to have an alpha channel for anti-aliasing. So it's a breaking change because the information that you have to provide is a little bit different, and in particular, you have to say what type it is rather than it defaulting to binary, which was fine in the past, but with LVGL, it's not the right choice. And I thought, well, what is the best default choice? And the answer is, if the default is, it's going to be wrong.
Yes.
So a few changes there needed in existing configs, but it'll make the operation much better in the future.
Yeah, when the images stuff started in ESPHome, there was only binary displays.
Yeah.
So it's around that binary was the default, and we don't like changing defaults as such, because if we change a default, then that's going to be a hidden break-in change for someone. So rather than changing it from binary to something else, we just outright make it required. And this becomes a very small breaking change for people.
It just needs a little tweak to the config, and then everything just works like it used to. There were a couple of bug fixes in there, well, not bug fixes, but there were some previous changes that introduced some unwanted side effects for some people, and this change cleans those up as well.
Cool. So those are, I think, some of the highlights for this release. The full details are here for anybody who's not familiar. I want to actually call this out because I think our documentation gets missed sometimes, and people come in and they're like, where do I find this information? So many of you watching probably already know this, but if you don't, we have ESPHome.io is the domain, and this is our front page. And so all of this stuff is linked here. The change log in particular is where you can go to find what we've changed in any given release. And that particular link will always take you to the latest release. If you scroll down to the bottom of this page, depending on how many changes there were, it might be a good little ways. But if you scroll down, then we also have the past change logs too. So this stuff is all available. If you've skipped several releases, it's worth it to go through here and look to see what might break when you try to update your devices. So I think it's worthwhile to call this out because, yes, I know people are, we certainly get cases where people are surprised by some of the changes we're making, and it's like, it's here. It really is documented, we swear.
No one reads. We know it.
It's true. Yeah.
It's been the bane of my customer support life forever, honestly.
Yeah. We're engineers. We don't need directions, right? We don't need
exactly.
No.
I buy something and open it and just throw the manual away. Like I'll be like, nah, I've got it. It's all good.
It's fine. I'll figure it out as I go.
That's not what I was supposed to be, and like, where did I put that manual?
Oh yeah. Oh, we've all done that. It's funny.
Oh yes.
But
wow. I think we're pretty covered up. Do we want to talk about anything for the future? I know Jesse Jesse has to go in 5 minutes, so we have to.
Oh gosh. We do have to
Yeah,
wrap up.
unfortunately.
We have some people that are going to be disappointed if we don't say something about the C6.
You want to explain what that is?
What's the C6? The C6 is the successor to the C3, which is the successor to the 8266. I actually, I'll call this out just because, Missy, if you want to put this screen up again. I wrote this last month because this question comes up all the time. Which ESP should I use? And I don't want to like toot my own horn writing this stuff, but I think it's important to kind of call out that like a lot of people are still using the 8266, and that's fine. But the C3 is the replacement for that. So if you're doing a project and you're like, well, the ESP32 is overkill, use a C3. If you have 8266s, that's fine. You can keep using them, but maybe don't buy more. Start looking at the C3. And the reason I bring up the C3 so much is because the C6 is kind of its successor. It's an improved C3. It's got a Zigbee radio, which can support Thread, so that's kind of cool. Now, we don't have support for that in ESPHome. Let's be clear. Zigbee and Thread matter. That's a topic for another day. But there is hardware in the C6 that could potentially support that. It's got updated Bluetooth. It's got several more GPIO. I think it's got like 6 or 8 additional GPIO pins. But other than that, it's pretty similar to the C3. But a lot of people are very excited about the C6. It also supports larger flash memory. The C3, I believe, is limited to 4 megabytes. With the C6, I think you can go up to 8. So if you've got large ESPHome configurations, that might be something to consider. In terms of, how well does it work? Are we supporting it? Well, it's kind of supported. I've used it since we switched to IDF 5.1, it is actually officially supported by that version of IDF. So if you are using IDF and not Arduino for your configuration, then you can, that should just work. At least it did for me. So
you can create a configuration using mostly defaults for AC6, and it will run ESPHome. There may still be some components, some peripherals that don't work. People
the
have
ADC,
been,
I think, is still one. Yeah.
The developers and the contributors have been working on updating components to work with the C6 over the past many months. Most of the stuff does work. Any of the basic stuff works. UART, I2C. It will work with most sensors, but there are a few things that don't work yet, and that's just a case of people working on it, getting it started.
It'll get there. There's definitely some work we still need to do to get full support for that, but it's very much in progress. We've already had quite a few contributors who've worked to get various hardware aspects of the C6 working right. So it will take some time, and once that's ready, we'll add it to this list. But for now, the C3 is a safer way to go. If you want something that's better than an 8266, but maybe not the horsepower of a C3, or rather, I'm sorry, an S3 or the original ESP32. So food for thought. But the other thing too is if you do use a C6 and you find something wrong, jump in Discord and at least make us aware of it. We may already know about it, but it doesn't hurt to mention that. I just got my first board yesterday that I drew up with a C6 on it, so I gotta maybe put this together after the stream. We'll see. I did a little revision to my IR blaster thingy, but in any event, there you have it.
Wow, that was a lot to go over for 6 months-ish since the last time. But
next time we'll have to make it 3 hours.
You know what? We're right on par for the last stream in June, so we're actually doing really good at the 1.5-hour mark. For all of you who are not aware, ESPHome is supported by the Home Assistant Cloud subscription. So if you would like to support all of us here who are making ESPHome, who work at Nabu Casa, sign up for Home Assistant Cloud for us. It's how we get paid. It's how we make more hardware for you. So this is how we end up doing all of these really fun things. I don't have a very specific date yet for when the next live stream will be for this. But we will have announcements ahead of time like we had for this one. And I'll make sure it's as agnostic towards our hemispheres as possible again. Absolutely. So
Yes.
awesome. Thank you guys. Thanks, Clyde, for joining
Yes.
us, for being our special guest. It was lovely. Thanks, Jesse. Also, because you're joining from the future. We love when you come visit us in the past. So, and Keith, who is our resident hardware guy who kind of hides in the background but loves everything he ends up doing. So,
Yes.
all right, guys. Thank you so much, and hopefully we'll see you guys soon.
Take care. Thanks for joining.